Matthew must be a man's name, right? Not a woman's name. Yes or no? Yeah, now you are actually. Hi, Matthew. Nice to see you. Okay, now don't forget, Monday the class is not off. Okay, you can still come here to ask any question about the fourth test, right? So Monday we still have class, right? Even though we'll not cover anything new on Monday next week, right? But we will still be here. I will still be here at least, right? To answer your questions. Any question you have.
Attendance be taken on Monday?
No, Tuesday, not Monday. So you can have more time to study for the.
No, will attendance be taken on Monday?
Yes, you are right. Sorry about that. I misunderstood you. Sorry, Katie. Okay, now remember, okay, our attendance is still taken on Monday. So class will not be called off on Monday because you can come to the Zoom session, right, to ask any question you have about the fourth test, right? So fourth test will include what? Will include optimization. This is from chapter 4, right? And Newton's method, and then anti-derivative. So 3 sections from chapter 4. I forgot the section number, but that's okay, right? Just know that optimization, that means you have to find the maximum value and minimum value, right? And the Newton's method and anti-derivative. So 3 sections from chapter 4 and 5 sections from chapter 5. 5.1, 5.2, 5.3, 5.4, 5.5, right? And this is the topics which will be covered on the fourth test, right? So therefore, let me give you the file. Okay, the file, you don't have to copy the file because the file will be sent to you after the Zoom lecture, right? And every time, remember, right? You got to pay your attention. You got to focus on this review, okay? So let me share the screen with you for the let me open it. Okay, good. Very good. Okay, let me share screen with you, okay? Yeah. Okay, can you see it? Right? Now, let me enlarge it for you, okay? You can see it. Can you see now? Okay, well enough, right? Okay, this is the okay, so okay, can you see it, right? I hope everybody can see it. Okay, so this is the Math 2114 test 4 review, okay? So this is first problem. Find a point on the parabola. This is from chapter 4, okay? Find a point on the parabola. You don't have to copy it, and the file will be sent to you after the Zoom lecture, okay? But you got to pay attention to this file, okay? To these problems. You got to pay attention to it. Don't let your attention wander, okay? Find a point on the parabola y squared equal to 2x that is close to the point 1,4. Actually, this problem is from what? Page 333 in number 3. The same problem. So please take a look at this one. If you have any question, ask me on Monday, okay? Ask me on Monday. Don't forget that. You have to take a look at in number 3. From that section, the page number is 333, right? Take a look at that. If you have any question, please ask me on Monday of next week, okay? This is first problem. This is from what? From the optimization, right? You want to find the point on the parabola that is close to the point 1, 4. So the distance should be what? The distance should be minimized, right? Okay, next is also from chapter 4. Okay, you have to write down the formula in Newton's method. So this formula you have to write. Okay, all you have to write is just this formula, no more, no less. Okay, so this is called the recursive formula, right? Xn plus 1 equal to xn minus fxn over f prime xn for n equal to 1, 2, 3, so on, so forth, right? So that's the formula in what? In Newton's method, okay? All you have to remember is the simple formula for the test 4, right? For the fourth test, for test 4, okay? So this is easy to remember, right? So there's only one formula, okay? Of course, you can do it by hand, right? If you have some function, right? But it's not required for this test. It just all is required of you is to memorize this formula, okay? You got to know how to write down this formula in Newton's method, okay? All you have to do for this fourth step, okay? Next, this is from the quiz yesterday, right? Remember, right? Look at the problem. Today is Thursday, right? We had a quiz yesterday. Evaluate the Riemann sum for this function, x squared minus x, and x is between 0 and 2, and with 4 subintervals, okay? With 4 subintervals, taking the sample points to be right endpoints. You see the problem from quiz number 10 yesterday, right? Now solution is you have to know how to solve it. You have to show your work, right? First, you want to find the length for each subinterval, right? Because these subintervals are signed, right? So delta x is the length for each subinterval. Total length is b minus a over n. N is the number of subintervals. Now a is 0, right? A is 0 and b is 2. So it's 2 minus 0 over n. 4 subintervals, right? So n equal to 4. So 2 over 4 is half, which is 0.5, right? Now you can what? Now you can find the intervals, right? See, this is 0, right? And this is 2, right? You divide this into 4 subintervals. So the half, and this is a quarter, right? This is 3/4, right? So this is x0, and x1 is 0.5, right? This is 0.5. Why is it 0.5? Because the length for each subinterval is 0.5, right? So 0 plus 0.5 would be. Now 0.5 plus 0.5 would be 1, right? 1 plus 0.5 would be 1.5. Right? And 1.5 plus 0.5 would be 2, right? So this is x0, right? And this is x1, and this is x2, and this is x3. The last number is x4. Okay, so we have to know that how to evaluate the Riemann sum, right? So the Riemann sum is sigma f. You take what? You take the right endpoints, right? Not left. So right endpoints for first each subinterval, you take these, right? This is the right endpoint for each first subinterval. For the second subinterval, you take this point, right? For the third subinterval, you take this point, the right endpoint. For the fourth subinterval, you take this point, right? So use this as height to evaluate f, right? So you have this. Sigma means sum, right? I from 1 to 4, 1, 2, 3, 4, right? And fxi times delta x. Delta x is the base. Fxi is the height, right? So use what? Use the area of these small rectangles to approximate, right? The area. Now fx1 will be f.5, and then will be f1, and then will be f1.5, and then to delta x is same, right? So we can put delta x outside, okay? 0.5. Right, now evaluate the function value at 0.5, right? So 0.5 squared minus 0.5 will be negative 0.25, right? Put a 1 inside, so 1 squared minus 1 will be 0. like f1.5, 1.5 squared minus 1.5 will be 0.75. f2, 2 squared minus 2, 4 minus 2, will be 2, right? And times 0.5, right? Now you can use calculator or you can even do it by hand, right? So the answer will be okay, right, will be this number is 2.5 times 0.5 will be 1.25. Okay, so the final answer for the Riemann sum for this function, right, will be 1.25. Okay, 1.25. Exact answer for the Riemann sum, no approximation, right? Because this is exact answer for the Riemann sum, not for the area. Okay, for the Riemann sum, this answer is 1.25, right? So you gotta make sure that you really understand how to use the Riemann, how to evaluate the Riemann sum, right? By following the instructions, right? You have forced intervals, you take the sample point to the right endpoint, not that. Okay, left the problems, the answer will be different, right? The right endpoint, right? And then you can evaluate this number. Next. You have to know how to find the derivative of this function. Okay, this is the this is what? This function defined to be integral from x9 to 1. The function is cosine t squared dt. How can we find the derivative? This means how we have to find f1, f prime x, right? Now, first, we have to use fundamental theorem of calculus part 1, remember, right? In order to use part 1, you have to switch the lower limit and upper limit, right? Because for part 1, the upper limit should be a function of x, the lower limit should be a number, right? So this is, you have to switch it. If you switch it, the function changes by sign, remember, right? So remember, this is dA, right? And equal to what? Equal to negative AB, okay? So I got to remember. If you turn AB along, the sign has been changed, okay? The sign has been changed, right? So you turn this, right? You shift, you swap lower limit and upper limit, right? So it becomes negative, okay? Fx go to negative because you swap it, then the originally is from x9 to 1, now from 1 to x9, right? So you swap the two, this is called the lower limit, this is called the upper limit, right? So you swap the lower limit and upper limit, so now become the, here the lower limit is 1. In the original function, the lower limit is x9, right? If you swap it, you change sign, don't forget that, okay? Now, you can take the derivative for f, right? By using the fundamental theorem of calculus part 1, right? Easy. Derivative negative is still negative, right? Now replace t by what? Right? By using the chain rule, right? Replace t by x9. We have cosine x9 squared. Now times the derivative of x9 by using the chain rule, right? So x9 derivative is 9x8, right? The cosine, this is 9 times 2, is t, so the negative sign, okay? Negative is becoming swapped, right? Okay, so final answer is this. It's negative 9 x to the power 8 cosine x to the power 18. Okay, by using so-called what? FTC, right? Fundamental theorem of calculus, part 1, remember, right? Okay, so we have used fundamental theorem of calculus, part 1. Of course, here we have to use what? The chain rule, right? The chain to find out why this is multiplication, right? Because of the chain rule. Remember, we have learned this, right? The chain rule. Okay, so final answer is negative 9 x to the power 8 cosine x to the power 18. Okay, so we have found, we have learned how to find the derivative of the function defined to be an integral, right? Okay, the final answer is this function. Okay, negative 9 x to 8 cosine. Okay, Let's continue with something. Now evaluate the integral. This is from chapter 5, right? All these are from chapter 5 now. How to evaluate this? This is called a definite, right? Because you have the lower limit is 1, upper limit is 9. Function is this, right? So final answer should be a number. Okay, should be a number. See, this is negative 76. How can you evaluate? Easy. You divide this, you split this into two parts, right? So square root of x over x minus 2x squared over x, right? And square root of x over x is x 1/2 minus 1, for negative 1/2, right? And these cancel x with 2x. So you can see that this is difference. So you can do term by term. Every term is a power function, right? So here you can use the power rule for antiderivative, right? So negative 1/2 plus 1 will be 1/2. So 1 over 1/2 will be 2, right? And 2x antiderivative is x squared. Then you can use what? Fundamental theorem of calculus, FTC part 2, right? So this is from 1 to 9, evaluate, right? Put 9 inside and put 1 inside, you what? Do subtraction, right? You do subtraction. The answer is negative 76. Okay? So for a definite integral, the answer got to the number, scalar. Now this is indefinite, right? This is indefinite. The next one. Right? This is indefinite. Why indefinite? Because you know you don't have what? Lower limit and upper limit, right? So this is called indefinite. This is also straightforward. You do term by term, right? This is ax cubed. You can write this as a power function, right? X, this is 7/3. So this is in the denominator. So this is negative 7/3, right? This is 9 over x squared plus 1 here. Now this is easy. X cubed antiderivative is 1/4 x4. Right? Negative 5 is scalar. Now you have to what? Remember this formula. We have used this formula many times, right? Use this formula, right? Antiderivative. This power function for antiderivative is what? 1 over n plus 1. Remember that formula? Basic formula, right? xn plus 1 plus c, right? If n not equal to negative 1, remember, okay? If n not equal to negative 1. If n equal to negative 1, this does not make sense, right? Or therefore, n equal to negative 1, the formula is right here, right? It's x1 over x, right? Antiderivative, everybody knows that is ln, right? X2 value. Okay, so we use first formula, because n here, n is negative 7/3, right? These are n, see? Right? So negative 7/3 plus 1 will be negative 4/3, right? Negative 4/3. So 1 over n plus 1, you flip that, right? You flip that. So negative 3/4, right? 3/4. And 9, 1 over x squared plus 1 antiderivative is inverse 10. Don't forget that, okay? Inverse 10. Not log, okay? Inverse 10. Okay? 1 over x squared plus 1 antiderivative inverse 10, right? Now simplify. 8 times 1/4 is 2, right? Negative 5 times this is 15 over 4, right? And this is, don't forget, for indefinite, you have to add c, okay, x, right? This is a function of x plus c, this is for indefinite, right? For indefinite. Okay? This is from chapter 5, right? Now we have here, now we have to use what? We have to use hot. Yeah. Let's look at the next one. How can we solve antiderivative for x plus 2 over square root x squared plus 4x dx? Here you have to use what? The idea from section 5.5 by using the what? Method of substitution method, or use substitution method, right? So here you let u equal to what? Right, then u equal to this. See, look at that, x squared plus 4x. Right, so naturally, you choose u equal to x squared plus 4x by using so-called u substitution method. Right, so now you can solve for du. Du is the differential. Is the derivative times dx, don't forget, okay? Derivative x squared is 2x, and 4x is 4. Now 2 is the common factor, you can pull outside, right? So here you have what? x plus 2 times dx, right? So divide by 2. So x plus 2 dx will be 1/2 dx. See? Right? See? Right? This is x plus 2 dx. Right? So you can write everything in terms of u now, right? X plus 2 dx will be 1/2 du. And this is square root u. Right? Now it becomes very easy. 1/2 scalar put outside. And this is 1 over square root u, which will be u to the power negative 1/2 du. Right? Now you can, again, use the what? Un, right? It's 1 over n plus 1, u to the power n plus 1. Now n is negative 1/2. Plus 1 will be 1/2, right? So 1 over 1/2 will be 2, right? So it cancels out. And you have to replace u back, right? Square root, this is 1/2 square root. U is x squared plus 4, right? Okay, it's easier to verify this is the right answer. How can we verify it? By using what? By taking the derivative to make sure that derivative is equal to this. How to find the derivative for this, right? Even though it's not required on test, but it's nice for you to know that your answer is right by doing this kind of simple verification. You take the derivative, right, to make sure that your derivative is equal to this by using the what? The chain rule, right? Power function, so 1/2 down, right? 1/2 down. And now you have what? X squared plus 4x, 1/2 minus 1, right? Will be negative 1/2. Derivative, not antiderivative, okay? Now take the derivative for inside. X squared derivative is 2x, and the 4x derivative is 4. Right? Now 1/2 times 2x plus 4 cancel 2, right? So you have what? X plus 2, right? Over. This is negative power 1/2 is square root. Underneath, right? X squared plus 4. Right? X squared plus 4. Same answer, right? The derivative for this function is x plus 2 over square root of square plus 4. So we have verified this is the right answer. Right? Even though this is not required on test, right? It's nice if you can make sure that your answer is perfectly right, right? By taking the derivative, ensure that the derivative is equal to the original function, right? This is the idea for the anti-derivative, right? What does this answer mean? It means that your answer, the derivative should be equal to the original function, right? So that's the part 3, okay? Oh. Yeah. Now let's look at part 4, okay? How to find antiderivative for this function. ln(x) cubic power over x. Again, you have to use what? Use substitution method, right? So use substitution method is highly useful here. Let u equal to ln(x). Okay, so let u equal to this. Okay, so what's du? Du is the derivative of ln(x), which is 1 over x dx, right? Now you can write everything in terms of u now, right? Because ln(x) is u, so u cubed. And 1 over x dx is du, right? Now it's easy to find antiderivative for u, right? It's 1/4 u4. Now you replace what? U back by ln(x). So this is the final answer. How can we verify this answer is the right answer? By taking the derivative. So let's do it, okay? Let's refresh your memory, okay? Because derivative is so important in calculus, right? And find derivative for this function. Make sure that your derivative is equal to 0, okay? And find the derivative by using the chain rule, okay? So 1/4, right? 1/4 is scalar. Now, power rule for outside, 4 down, right? And ln(x), 4 minus 1 is cube, right? And then you can ignore 4, take the log x derivative, which is 1 over x. Right? So cancel out. So you have what? You have the derivative is log x cubic power, right, over x. See, same thing, right? Right? So this answer is 100% right. If you cannot verify your answer, it means that your answer is wrong, right? If you can verify that your derivative is equal to the original function, then your answer is 100% right? Okay, this is part 4. Okay. Now let's look at part 5. Okay, part 5.
Hi.
Someone who mute. Okay, good. 1 plus x over 1 plus x squared dx. How can we find antiderivative for this function? Right? Here, if you want to, somebody, oh, I want to use substitution. Yes, you can. But you have to make sure that you really understand how to use. Somebody say that u equal to 1 plus x squared. Right? That's very natural choice here. So that u equal to 1 plus x squared. Okay, so you want to evaluate for du, right? The differential of u du is the derivative times dx, the derivative of 2x dx. Right, but unfortunately, the numerator is 1 plus x, is not x or 2x. So what should we do? Easy. You split this into 2 parts, right? 1 over 1 plus x squared, this is the first part, and you have x over, right? So x over 1 plus x squared dx is the second part, right? This is sum, so you can do it term by term. Now for the first part, the antiderivative is very easy. That's inverse 10, right? Inverse 10. And for the second part, you can use this method, right? To handle the second part. See, this is x dx, this is x dx, right? So the answer is this. Let me do it. Why this is this, okay? Because I want to show you the steps, okay? So here you can write this as what? 1 plus x squared is u, so it's 1 over u, right? And x times dx, x dx is 1/2 du, right? 1/2 du. So this is 1/2 scalar put outside, right? So 1/2. And inside is 1 over u du, right? Now this is easy. Antiderivative for 1 over u is straightforward. Antiderivative, not derivative, okay? 1/2 ln absolute value u plus c. For the second part, okay, for this part, okay? Now put a u. Absolute value, u is 1 plus x squared, right? We have 1 plus x squared plus c. Now, since 1 plus x squared is always positive, right? Because x is a real number, so you don't have to use absolute, because this quantity is always positive. So absolute value is redundant. So the answer is 1/2 ln 1 plus x squared. See, right? This is the second part, right? Add c because this is indefinite, right? So the second part is 1/2 ln 1 plus x squared, right? So we have found the answer. Okay, we have found the answer. How can we verify it? Easy to verify. You want to make sure that this derivative is equal to the original function, right? Let's take the derivative. For inverse 10 derivative is 1 over 1 plus x squared, right? Now for this derivative, this is sum, so you can do term by term, right? For this derivative, you have to use the chain rule, right? 1/2 ln is 1 over whatever inside, right? 1 over 1 plus x squared. Now you can forget ln. This derivative is 2x by using the famous chain rule, right? Now you can simplify. So this is 1 over 1 plus x squared plus 2 have cancelled out. So it's x over 1 plus x squared. Same common denominator 1 plus x squared. So the numerator is 1 plus x. Same thing, see? Right? Right? So 1 plus x over 1 plus x squared. Right? So Now we have fully verified that this is the right answer, right? This is the right answer. Okay, very good. Now let's look at the next problem. Okay, look at the next problem. This is definite, okay? From 1 to 2, right? E to the power 1 over x squared dx. So the final answer should be a number, okay? Final answer should be a number. Here, again, you have to use what? You have to use the use of substitution method. So here is 1 over x, right? So then u equal to 1 over x. Now you have solved for du, right? Du is the derivative, not antiderivative, okay? Derivative, this is x to the power negative 1, right? So derivative is negative, this is minus 1, so 1 x squared dx, right? So now for the definite, you have to change the lower limit and upper limit for the definite, remember, right? So for x equal to 1, what's u? U equal to 1 over 1 is 1. For x equal to 2, what's u? U is 1/2, right? Put 2 inside, okay? Now you can write everything in terms of u, right? So the 1 is the new lower limit. It happens to be same, right? But the new upper limit for u is 1/2, right? So 1/2. So 1/2. E 1 over x is u, and the 1 over x squared dx will be negative du, right? So put negative sign outside, antiderivative for EU itself, right? Put by using FTT2, right? 1 to 1/2. So put 1/2 inside, and this will be negative e to the power 1/2 minus put 1 inside, right? So distribute negative sign. E minus e to the power 1/2, or you can write e minus 2e. So either this way or this way. Okay, so this is the final answer to this part 6. Okay, this is definite, right? So final answer is e minus square root e. Okay. So this is the fourth test review for today. Okay, you can finish early today. So we have finished. This is the last one. Okay, this is the last one. This is the last one. See, no more, right? No more. So this is the last one. This is the last problem. Okay. So this is part 6, right? Part 6. So you got to in this class, in this test, you got to know how to handle the integral, right? The chapter 5 is very important for this fourth test, right? You see a lot of problems are devoted to the Riemann sum and to the how to find the derivative for the integral function, right? And how to evaluate, either by using tables, formulas from table, or use what? Use substitution method, right? So we have finished the review for fourth test. The file will be sent to you in a few after Zoom lecture. But please ask questions if you have any questions to ask. You can either ask today or ask me on Monday next week. Okay, the test will be Tuesday, right? Please ask if you have any questions about this review. Okay, about this review. If you don't, you can sign your name. So we can finish early today, right? We can finish early. Sign your name.